All right, everyone, let's talk about how to find the slope or rate of change of a linear function, right? A linear function or a linear relationship. So let's take a minute and try to understand maybe a subtle distinction. So the rate of change, all right, that's a property of the relationship, right? That's how much the value of the function or the value of the relationship changes by, right? The slope is a property of the line that we use to model the relationship. Okay? Like let's say we had this relationship graphed right here. And let's say this is again fine for an overdue library book. Okay? Let's say this is the fine for an overdue library book. So the x-axis is going to represent the days overdue. The y-axis is going to represent the amount of the fine, okay? So we can see here that at 1 day overdue, you have a fine of $5. At 2 days overdue, you have a fine of $6. At 3 days overdue, you have a fine of $8, okay? So what's the rate of change of this function? The rate of change of this function is positive 2, right? So if we write y equals, rather, let's write f of x equals mx plus b. If f of x equals mx plus b, right, the rate of change is m, and in this case, m equals 2, right? That's easy to figure out in this case because we see that we have each successive value, right? On the first day, it's 4. On the second day, it's 6. On the third day, it's 8, right? We can see that the rate of change is positive 2 because we're given each output in order, right? But what if, let's just say, what if we weren't given these amounts? Let me erase some stuff, okay? Actually, let me erase more than that. Let's say we weren't given these amounts. Let's get rid of this here. Let's say we were only given the fact, okay, that the first day the fine was 4, right? And let's say we weren't told what the next fine would be up until day 5. And let's say we knew that the fine on day 5 was it'd be $12, right? We know that, but let's say, yeah, let's say we know that the fine on day 12 would be, sorry, the fine on day 5 would be $12, okay? Now, before, on our first set, when we had 3 points for day 1, then the next day, day 2, then the next day, day 3, right? It was easy to figure out what the rate of change was. But here, we're given 2 points that are, kind of far away from each other, right? We're given the point 1 comma 4, and we're given the point 5 comma 12, right? So how can we figure out the rate of change easily? Well, we can take these 2 points and consider them as part of this linear function, right? They're a linear relationship, right? So we can consider them 2 points on a linear function, right? Let me get my writing tool back. So we have 2 points. It's a linear function, so we can consider this a line, right? We can consider this a line, and to find the rate of change, we can find the slope of the line. We can find the slope of the line that we use to model this function, okay? And does everyone remember how we find the slope of a line? Hopefully everyone remembers the change in y between any 2 points divided by the change in x between any 2 points, right? Or it's often remembered in the terms rise over run, right? Rise over run, or change in y over change in x. Sometimes it's written as delta y divided by delta x. That just means change in y divided by change in x. That triangle sign means change. And so we can calculate that between any 2 points, right? And remember, when calculating the slope of a line that is joined by 2 points, remember that we always go from the leftmost point to the rightmost point, right? We always start at the lower x value going towards the higher x value, right? So between the point 1 comma 4 and the point 5 comma 12, what's the rise? Well, the rise is the difference between 12 and 4, right? That's 12 minus 4. 12 minus 4. And what's the change in x? The change in x is the difference between 5 and 1, right? That's 5 minus 1. How far you go to the right, right? So change in y is 12 minus 4. That's 8, isn't it? Because we went from y equals 4 to y equals 12. So we had to go up by 8 units. Divided by 5 minus 1 is 4, right? Because we started at x equals 1 and we went to x equals 5. So we had to go to the right by 4 units. And what is 8 divided by 4? It's 2, right? So even if we were given 2 points far away from each other, so far away that it's not too easy to immediately recognize what the rate of change is, we can always find the slope of the line that joins those 2 points, and that is the rate of change of any linear relationship or linear function. Okay, everyone, let's look at this example. Okay, a business is growing its revenue at a constant rate. Okay, since we're told that the value or the output of this relationship is growing at a constant rate, we know it's a linear relationship. So we know we can represent this as a linear function. Okay, it's growing at a constant rate. In its third year, it had a revenue of $14,250. In its 18th year, it had a revenue of $20,370. By how much is this business's revenue growing each year? Okay, so this might not be too easy to figure out immediately, right? There's a 15-year difference, and there's a difference in, it looks like a couple $1,000s, right? So it might not be obvious right away what the rate of growth is, okay? So let's remember that the rate of growth or the rate of change is the amount by which the revenue is growing each year, right? That means if we considered this as a line, if we considered this relationship as a line, y equals mx plus b, okay, where y is going to be the revenue each year, right? Revenue each year. Y is going to be the revenue each year. X is going to be the year, right? The independent variable or the input in this relationship is the year. The output or the dependent variable is the revenue for that year. What's M going to be, right? M is going to be the rate of growth. It's going to be the rate of growth. That's going to be by how much the revenue grows each year. It's also going to be the slope of the line, right? It's going to be the slope of the line that we use to represent this linear function. And b is going to be the y-intercept. We're not going to worry so much about figuring out the values for b in this video. In this video, we're really focused on being able to figure out the rate of change, okay? So let's focus on figuring out the rate of change, all right? So let me make some room for us to work. We know that the rate of change is going to be the slope of the line, right? We know it's going to be the slope of the line, m. And what do we know about slope? We know that slope is equal to, let's call it rise over run, right? Rise over run, or change in y, that's the change in the y coordinate, divided by change in x. That's the change in the x coordinate. So we need our 2 points, right? What's 1 point? We know 1 point is 3, comma, 14,250, right? Because let me get rid of that second, let me get rid of that second comma just so we don't confuse ourselves. Let me write these coordinates without commas. So let me just write 14,250 like this, 14,250, okay. That's one data point, right? Because we know in the third year, there's a revenue of 14,250. And on our other data point we're given, we know that data point has the x coordinate 18 for the 18th year, and it has the y coordinate 2,370 because there's a revenue of 20,000. Sorry, the y coordinate is 20,370 because there's a revenue of $20,370 in the 18th year. So we can calculate the change in y over the change in x. All right. So The formula for that written explicitly is y2 minus y1, okay, divided by x2 minus x1, all right? And your first point is always your point with the least x value because we're always going from left to right, okay? So the point with the lower x coordinate is x1, comma xy, right? Sorry, x1, darn it, it's x1, comma x1, comma y1, right? The first x coordinate and the first y coordinate. And our second point is the point with the greater x value. So that has your second x coordinate and your second y coordinate, right? So the x coordinate goes from 3 to 18, right? And your y coordinate goes from 14,250 to 20,370, okay? So both quantities in this case are increasing. So let's replace this numerator. Y2 minus y1 is 20,370 minus 14,250, right? Let me draw our division sign larger. And let's replace x2 minus x1. Let's replace that with 18 minus 3, right? We went from 3 to 18. Okay, so let me get rid of this here so we have some room to calculate. Okay, what is 20,370 minus 14,250? That's 6,120. Okay, that's 6,120. If you go from 14,250 to 20,370, you increased by a positive 6,120. What's the difference in the x coordinate? That's 18 minus 3, that's 15. If your x coordinate goes from 3 to 18, you increase by 15. Or if you went from your third year to your 18th year, you increased by 15 years, right? So let's calculate that. 6,120 divided by 15, that's 408. So that's the slope. So we found out that m equals 408. And remember, the slope of the line connecting these 2 points is the rate of change of the function that the line models, right? So the rate of change of the of your revenue for this business is $408 per year.